Good morning, everybody. Nice to see everyone in Blackboard. Go ahead and give me a green check. I'll let you guys know what we're going to do today. Obviously, we don't have any new material to cover, so we're not going to go through anything in terms of new stuff. But I wanted to go through any questions you had out of 9.2, Chapter 9 Learning Guide in general. We didn't cover a lot of stuff with regards to graphing motion with acceleration, velocity, time graphs. So we can go through some of that. I want to talk a little bit about tomorrow, what that's going to look like. And I also wanted to talk a bit about what the next 2 weeks are going to look like and what we're going to do in terms of preparation for the final exam. So if you do have any questions out of the Unit 9 Learning Guide, you can put them in chat. I'm just going to go through a few things and then I'll come back to that in a second. Let's talk about tomorrow first. Tomorrow, if you recall, I've got a lab or just a classroom for us at KSS. And we're going to go and use some, it's called LabQuest. It's these little handheld data recorders and motion detectors and things like that. We're going to go in and just do a lab because we don't get to do a lot of labs. Obviously, you guys are at home. So I thought it'd be kind of fun to do something like that. So I will be in the front foyer of KSS. If you walk in the front doors, I'll be there at about 8:45. So if you get dropped off around 8:45. And then we're going to go to room 141, which is kind of in the left hallway. I'll draw a little map here in a second. And we're going to do the lab and we'll be done at 10:15. So if you want to get picked up at 10:15, that'd be great. Or if you are considering attending KSS next year, you can stick around and I will take you for a tour of the school. I'll show you where all of the different, we'll take you all around upstairs and downstairs so you know where kind of the science wing is and the English wing and the computer labs and office and gym and all that stuff. So kind of give you a lay of the land. So if you want or are interested in attending KSS, I can, take you guys through the school and you can see where everything is. And if you just want to come around for a little walk afterwards, you can do that as well. So if you're going to stick around for the tour of the building, take about 20 to 30 minutes to get through the whole thing. So then if you get picked up at about 10:45 tomorrow, that'd be great. So that's kind of what tomorrow is all about. I think Mrs. Wood just right now emailed the parent permission form, which you guys need to bring with you. If you don't have that filled out, I'll have a few with me tomorrow and then you can just, run them out to your parents, get them signed off on. So if you can print it, bring it tomorrow. If not, I'll have a few blank ones and you can get them signed tomorrow. I know it's kind of a pain, but we have to do it for every event. So there you go. That's tomorrow. Does anybody have any questions about tomorrow? Taylor, what are you going to do? I will email the students who don't come. I'll give you guys, there's like an online simulation that's in the course, and I'll send you out some information and a sheet as to what to do. Should we bring anything? That's a good question. Probably should have covered that. You should bring a pencil, some blank paper, and just that should be good. Maybe a calculator as well. We'll do a little bit of math. If you come with some paper, pencils, calculator, that would be great. If you don't, we can find it for you. Avery, no worries. I will send that stuff out to you. And same with you, Taylor. I know you're down on the coast. So we'll get you guys an alternate type assignment to do. There's no need to wear safety glasses. There's going to be nothing flying around, hopefully. No safety equipment required, which is nice. All right, so that's tomorrow. I want to talk a little bit about the end of the course, where we're going. And here we go. So in the course, I just uploaded a new, I shouldn't say I just uploaded, I just kind of moved it. So the other day somebody asked, hey, Mr. Borden, do we have a final exam? And I thought, no, I don't want to force you guys to do that. But then I thought, well, we should have some sort of preparation for the final. So what I've done is I have a document. There are sort of two sections here that say provincial exam prep, but right here where it says final exam prep, you must do one. I've uploaded this year-end review, so it's just a PDF document. It goes through all of the sections in the course, asks some questions, has pictures and things and diagrams, and just covers everything. So it's fairly long. I mean, you guys still have 2 and a bit weeks, so you'll have plenty of time to get through it. So I'm gonna leave you that, or I'm gonna put in a provincial exam, like an older one that I have, and you guys can do that if you want as well, or one or the other. If you do both, I'll take the better of the 2 marks. I mean, I want you guys to do at least one of these things. This chemistry review I kind of kicked in here as well. It says optional, and it is optional. It's probably about 5 or 6 pages of just chemistry stuff. And the chemistry stuff is probably the trickiest part of the exam. So if you definitely are looking to do well, you want to go through that as well. So I don't want to throw a ton of work at you here at the end of the year, but you do need to sort of prepare. So the year-end review, you can do that and fill it out and give it back to me. Just email it to me, or I'll put an assignment in there. Or you can do a provincial exam. So I'm going to upload a new provincial exam tomorrow, and you can do that alternatively. So the chemistry one isn't, like, all of this chemistry stuff's actually covered in the year-end review. So you don't have to like do one of these two. Now that I look at this, is kind of confusing. So it says you must do one, but there's only 2 things. I'm gonna put in a few more things here. A couple older exams I'll put in. The year-end review. This chemistry review is optional. It just has a lot of chemistry stuff. It's worth looking at. Just kind of go through it. I'll put in some solutions to that in after about a week or something. I'll give you guys so the answers to all that stuff. So yeah, that would be kind of like your review for the final exam. You can do the year-end review. You can pick a provincial exam. I'll put a few in there, and you can do one of them. And just kind of, with the provincial exams, you just need to submit your solutions to me. And in terms of like A, B, C, or D for each question, easy peasy. And I'll give you guys a mark, and then we can go through it. So is it open book or a test? I'll just say it's open book. I mean, test yourself as best you can. I just want to make sure you're preparing for the final exam. I'm not here to, drill tests into you guys. So you do what you have to do. I would, if I were doing it, I would probably go through a closed book and then look at some of the stuff that I maybe couldn't answer, go back through it again with my notes, see if I can answer those questions. And that way you kind of know what you need to really focus on in terms of studying. A lot of times students, when they prepare for exams, they spend all of their time focusing on the things they know because it's easy. You go through the questions, you understand, and you're answering them, and you feel really good about yourself. And then you get to something you don't know, and you kind of skip it. And then you need to go back and redo it, learn it again, or review it, learn it for the first time maybe. That takes more work. So students kind of tend to avoid that because, it's the path of least resistance is just doing the questions you know how to do. So a lot of times students will focus on things they know, when if you know it, you should just really just gloss through it and go to the things you don't know how to do. So I'll add a few things in here as we go through the next few weeks, and there'll be lots of sort of options. Just pick one. You can do all of them. Doesn't matter to me. I just want to give you guys exposure to the types of questions you're going to see. So there you go. All right, so we talked about tomorrow, talked about kind of the review process. We need to talk about the questions you guys had. So I noticed you guys put a ton of things in here. All right. Sorry, Avery, I'm just reading your question now. Will we hand it in online, or will we hand it in at the provincial? Yeah, hand it in online. I'll put in a spot. I'll put in like an assignment, And no matter what you do, just upload it there. Just like, it'll say like upload your choice here, and then I will mark that, whatever you upload. So if it's the review, the like fill in the blanks review, perfect. If it's a test, I'll mark that, that's fine. So you'll be able to submit it online. All right, I'm gonna scroll back up in my chat here. Can we go over page 2, number 11, page 3, number 13? Page 2, number 11. Okay, I'm just gonna circle them all and then we'll see if we have any duplicates. Page 3, number 13. You look at page 6, number 10. If I don't circle your question, let me know. Page 6, number 10. It's a tricky question, that one. Page 2, number 6 and 8. 1, 2, 6, and 8. All right, I think I got them all. If I didn't, just kind of throw it in, or if something else comes up, let me know. So page 1 was good. Page 2, toboggan accelerates from rest to 1.1 at 1.1 meters per second squared. After 10 seconds, how fast is it going? Show the equation in all steps. Okay. One thing that I probably should have been more clear about, but it only frustrated myself, was in the Unit 8 learning guide. When you guys do questions in physics, when you use an equation, it's really important to write the equation down and then put information into the equation. Not only does it mean you'll make fewer mistakes, it makes it a lot easier for the person who's marking your work to follow through your sort of thinking process. Now, in Science 10, our physics problems have 1 or 2 steps. They're pretty straightforward. The equations only have 3 variables. But when you get into Physics 11 or Chemistry 11, I'm not sure what biology looks like, you'll get into equations that'll have 5 or 6 parts to them, maybe 2 or 3 steps. And if you're not writing your equations down, if just a bunch of numbers appear, it's really hard for the person who's trying to follow your work to kind of see or think about what you were trying to do or trying to accomplish. So as just a general rule, always write down the equation you're using. If you are putting numbers into the equation, it's a really good habit to include units, and your answer should always include units, and if it's a vector, you should also have a direction with it as well. Sometimes you can include that, sometimes you can't. Alex, I see your question there. I'll get to those for sure. So after 10 seconds, how fast is it going? Show the equation in all steps. So I think this is going to be a 2-step problem, if I'm not mistaken. Toboggan accelerates. All right, so this 1.1 is our acceleration. We have this 10 seconds, which is our time. And then how fast is it going? That's asking for a velocity. I also see that it says from rest here, which is an important piece of information. That means our initial velocity is 0. So when I say v over here, how fast is it going? We're trying to find the final velocity. All right, if I jump into my equation sheet down at the bottom here, I'm trying to find the final velocity, and I have acceleration and time. So I'm going to need to use some combination of the equations on the second half of the page here. I know I have the acceleration, and I know I have a time. Those are both given. So I can use all of these formulas because they all contain acceleration and time. I'm trying to find the change in velocity because if I can find the change in velocity, that'll allow me to plug it in here and find the final velocity. So you can kind of see how this is going to take 2 steps. We're going to first have to solve for the change in velocity. And then once we know the change in velocity, we know the initial velocity, we can find the final velocity. So this is one of those things where just kind of exposure to these types of questions is going to allow you to be able to answer them a little bit better each time. So delta V is acceleration times the time. We're going to start with that. So change in velocity is our acceleration multiplied by our time. I'm going to write down the equation, and then I'm going to plug information into it with the units. And I want to make sure my units match up. That's why it's important to include units, because sometimes we'll try to trick you. The acceleration is 1.1 meters per second squared, and the time that it does that for is 10 seconds. So 1.1 times 10 is going to give me 11 meters per second. So my change in velocity is 11 meters per second. Now, one really interesting thing about this question, it says it starts from rest. So I know my change in velocity is 11, and it started from rest. What's my final velocity going to be? Well, I can just use my brain to kind of figure that one out because it's going to be 11. Or I can write down the formula. So the formula including the final velocity was final velocity is the initial velocity plus the change in velocity. So the final velocity was the initial, which was 0, and the change I just calculated to be 11. Go up here. My final velocity is going to be, bump that over a little bit, 11 meters per second. And it doesn't say any direction, so that's the maximum amount of information I can include there. So 2 steps. First, you need to find the change in velocity. Once you've done that, then you can find the final. Or you can just kind of think about what's happening and go from there. How much time does it take a car traveling south at 12 to increase its velocity to 26? If it accelerates at 3.5. Again, 2 steps to this. They're giving you initial velocity and a final, so you're going to have to find your change in velocity. And then once you've done that, you're going to have to find the time. So, how much time does it take? That means find the time, but I don't know what it is. If I'm traveling south at 12, that's my initial velocity. I'm increasing it to 26, that's my final velocity. And I have this 3.5 is my acceleration. So if I go back to my formula sheet, I know my time, that's what I'm trying to find, is the change in velocity divided by the acceleration. So let's start with that. I write down my formula. Time is change in velocity divided by the acceleration. But I don't know my change in velocity. So a change is always going to be the final minus the initial. And in this case, my final is 26, and my initial is 12. So 26 minus 12, it's going to be 14. So I can now plug that 14 into the equation here. So 14 was my change. My acceleration was 3.5 meters per second squared. And I have to break out the calculator for this one. 14 divided by 3.5 is 4. And because my answer is a time isn't a vector, so I don't need to include a direction with that. I can just say it's 4 seconds. All right. Alex, you asked about page 6. We're not there yet. A stone is dropped from a cliff. What is the velocity after 1 second and 2 seconds? All right, there was a question like this in the notes, I think. So here's my rock. I want to have its velocity at 1 second, and then it's going to fall a little bit farther. I want to find its velocity at 2 seconds. Okay. Students kind of get confused on these types of questions because there isn't a lot of information given. And that's what makes it tricky, I guess. So things we do know. I know that I'm going to have to do sort of two problems. I have a time and another time, so kind of two parts to the problem. What else do I know about this stone? Or sort of, if you think in terms of variables, what variables do I know that aren't included in the question? Things that just, you know, are kind of embedded in there but not explicitly said. What do we think? You know, it'll be accelerating at 9.8 meters per second squared because it's free falling. Yes, so because it's an object in free fall, the acceleration is going to be, we'll call things going down negative. So I'm going to say A is negative 9.8 meters per second squared. So you guys all got the acceleration. What was the other thing that we forgot or that we know in the question? So we have the acceleration for sure. That's still not enough to find anything. Well, I guess it is. We could find the change in velocity. But we're not interested in the change of velocity. We're interested in how fast it's going after 1 second. And Alex, you're right. It's dropped, so the initial velocity is 0. Anytime an object's dropped, initial velocity is 0. Perfect, you guys are all on the right page here. So your initial velocity is 0 meters per second. So that gives us enough now to figure out the velocity. I can jump over to my equations. I see that velocity is my acceleration times my time, or delta V is AT. So let's start with that. Change in velocity is the acceleration multiplied by my time. So I'm going to have to do this for 1 second, and I'm going to have to do this for 2 seconds. So this is my 2 second, this is the 1 second calculation. All right, so the acceleration is negative 9.8 meters per second squared. My time is 1 second. So my change in velocity is going to be negative 9.8 meters per second squared. That's weird. Or maybe it's not. If I know it starts from 0, then I know my final velocity is going to be at 1 second, 9.8 meters per second squared. I can write something like at 1 second, just so I'm clear. So if it starts from 0 and it's changing by negative 9.8, then it means that it's going to start at 0. After a second, it's going to be traveling at negative 9.8. And that's true of any object in free fall. We ignore air resistance. Any object's going to fall after 1 second, it'll be going 9.8, as long as it's not thrown or anything like that. If any object's dropped after a second, it'll be traveling at 9.8, going down. Same process here, 9.8 meters per second squared, and in this case we're going to multiply by 2 seconds. So my change in velocity is going to be negative 9 and 9 is 18. Just reading your question here, Abby. 19.6. No, I had 14. Negative 19.6 meters per second. All right, Abby, your question said, why is s squared, the unit should cancel and velocity isn't squared? Just find some space here. I'm going to ignore the numbers and I'll just go with units. So I had an equation that looked like delta V is my acceleration multiplied by my time. So my acceleration is measured in meters divided by seconds squared, and my time is measured in seconds. If I want to just exaggerate everything, this is seconds over 1. If I want to put it all over one fraction, I could do that. Just write it here. Meters times seconds divided by seconds squared. My seconds on the top cancel with a 1 on the bottom. And then I end up with just meters divided by seconds, which is what I was hoping for because it's a velocity. Oh, that was my mistake I see here that I've written squared. I see why you're confused, because I was doing something wrong. Yes, so it's negative 9.8 meters per second. Just a habit to write meters per second squared. Sorry to confuse you and then try to explain it to you like you were a 5-year-old after I made a mistake. Oops. All right, so that was 11. We okay with 11? All right, let's scroll down a little bit. If you throw a rock up into the air, when is the velocity 0? What is the acceleration when the velocity is 0? So this number 13 is more of a conceptual sort of thing. It's not an actual calculation type question. There's no numbers to be put in. It's just asking, if I throw my pen up in the air, it's going to go up, it's going to hit its highest point, and then it's going to come back down. So when is the velocity 0? As soon as it leaves my hand, it's slowing, till it comes to a stop. So its velocity is 0 at its highest point, and then it speeds up going down. So velocity is 0 at highest point. And the acceleration. What is the acceleration for an object in free fall? Doesn't matter if the object's going up, down, sideways, forwards, backwards. As soon as it is let go of, the acceleration is always going to be the same. So it doesn't matter what the object is initially doing, it's always going to have an acceleration of 9.8 meters per second squared. As soon as it leaves my hand, at its highest point, just before it hits the ground, as long as it's in the air and not being touched by anything, it hasn't hit the ground or it hasn't hit some object, it's always going to have an acceleration of negative 9.8 meters per second squared. Always. No exceptions to that rule. So any object in free fall will accelerate towards the center of the Earth, negative 9.8 meters per second squared. Doesn't matter if it's going up, stopped at the top, coming back down. If it's in free fall, that's what its acceleration is going to be. No exceptions. 3, 17, you guys were... there are answers for number 17 on page 4, where you had to circle these things. Some of these answers are wrong. I don't know why, but I'm not going to tell you which ones are wrong. I was just looking at them and I was like, that's not right. No, that's not right either. So I think at least 2 of them are wrong. Number 17. So if you were just copying answers out of the back of the book for number 17, you might want to go back and look at it again. So 2 or more are wrong. I'll just go some are wrong. So be careful on that. Down to page 5, no questions. Page 6, Alex, you had a question, I believe. Page 6, 9 and 10. Perfect. It's funny you guys should ask these questions. These are questions that I've never seen in Science 10. There's a lot of material in this physics unit, part of the learning guide, that isn't covered in Science 10, but it's here, so we might as well do it. Use both the area and equation to determine the displacement traveled in the following graph. All right. So essentially, when you have a velocity time graph,
The area under the graph is actually the displacement. How does that work? Well, if I multiply my length here by my width, what am I doing? Well, I'm multiplying my velocity by a time. And if I go back to my formula sheet, a velocity times a time is a displacement. So distance traveled is the velocity multiplied by the amount of time you're traveling at that velocity. This is a really, really complex idea. Not really complex, I mean it's an area. You guys know how to take the area of a rectangle. But it's not a grade 10 concept. We'll do it anyways. So this is the object here, this line that's drawn on here. It's traveling at a constant 10 meters per second forward for 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. So that means the displacement is going to be the velocity multiplied by the time. The velocity is 10, and the time traveled at 10 is 5 seconds. So the distance traveled is going to be 50 meters. And I don't have a direction, so I can just write 50 meters. And then I can write area is going to be length multiplied by width. Let's think of a big yellow rectangle here. So the length of my rectangle we'll call this length up here. From this to this, the length is 5, and the width is going to be 10. So if I take my length, including units, it's going to be 5 seconds. My width is 10 meters per second. Length times width is 50 meters. So that was a velocity time graph, and we're actually getting a distance from it, or a displacement, which is kind of a weird thing. We didn't really talk about it in the notes. It's not super important that you know it. It's just kind of a question that popped up there. So, Abby, you are right. For some reason, I thought velocity time graph represented acceleration. If we were to take the slope of the line, it would give us an acceleration. So if we look at it real quick, I have a horizontal line here, so 0 slope. It's not accelerating. That's fine. And if we think about it in terms of these points, my first point here, after 1 second, I'm traveling at 10 meters per second. After 2 seconds, I'm traveling at 10 meters per second. After 3 seconds, I'm traveling at 10. You guys get the idea? I'm always traveling at 10 meters per second. So I'm not speeding up, not slowing down. There's no acceleration. Horizontal line means no acceleration. Just kind of makes sense. The second question is the exact same question as the previous one, except instead of having a rectangle, now I have a triangle. So use the area to determine the displacement traveled. So I have this wonderful triangle here. And if we think about this, like I was just describing in the previous question, this one is accelerating because the velocity is increasing. I read my graph really carefully. I see that it's a velocity time graph. After 1 second, I'm traveling at 4. After 2 seconds, I'm traveling at 8. 3 seconds, I'm traveling at 12. You can see as time goes on, this object is speeding up. So that is a slope that's increasing. It's going up to the right. That means it's accelerating. Should all make sense. Let's take the formula first. Displacement. All right, so my displacement is going to be my change in velocity multiplied by my time. So this is using the formula instead of using the area. So we're going to do the area second. So the change in velocity. I know a change in velocity is going to be my final velocity minus my initial velocity. So my final velocity at 5 seconds is going to be 20. My initial velocity at 0 seconds was 0. So 20 minus 0 is going to give me 20 meters per second is my change in velocity. So my distance or displacement is going to be change in velocity is 20, and my time was 5 seconds. My units again, 100 meters, 20 times 5 is 100. All right? The second part of the question asks me to use the area under the graph to determine the displacement, which is going to be the exact same thing. If I have the area of a triangle, it's going to be base times height divided by 2. The base of my triangle is going to be 5 seconds. The height of my triangle is going to be 20 meters per second. So I'm going to have base is 5 seconds. Height is 20 meters per second. I'm going to divide that by 2. What am I doing wrong? Base 5, height 20. Change velocity. Oh, I know what I did wrong. The first part I did wrong. All right, sorry. I'm gonna have to come back to that. I'll tell you why in a second. So 5 times 20 is 100. And I have meters divided by 2. It's 50 meters. No, there won't be questions like this on the provincial. I made a really big mistake here where I erased all this stuff. And that really big mistake was I used the formula velocity is, or let's just go, velocity is distance divided by time. I can only use this formula if an object's traveling at a constant velocity. In this case, the object is not traveling at a constant velocity, so I can't use this formula. And then I did. It was a cardinal sin of physics. I should have known better. In order to use a formula to solve this guy, we're going to have to find the acceleration, and then we're going to have to take a step back and find the distance traveled from the acceleration. I'll write a little note in here. Can't use if accelerating. Yes, I use d as change in v times t. And all right. I'm thinking by the time I end up solving this thing, it's not really going to be worth it. Suppose I could. Let's just do it anyways. Don't have anywhere else to be. This acceleration, we need to find the slope of a v versus t graph. All right, let's pick 2 points. Erase all this stuff. All right, there's my 2 points. I have 0, 0, and I have 5, 20. This is a change in velocity over a change in time. All right, Change of velocity. So my y2 is going to be 20 minus 0 and my change in time is going to be 5 minus 0. So 20 divided by 5, my acceleration is 4 meters per second squared. Are we happy with that? I'm happy with that. All right, so that's found the acceleration. Now, if I start at 0 and I accelerate at 4 meters per second, for 5 seconds, why is no matter what way I look at this, it's not working out in my head? I'm afraid I'm going to have to get back to you guys on this. Obviously, it's not super important that you know how to do it for the provincial. I'll leave it there. I'm a step ahead of myself here, and I just can't think of a way that this is going to work out nicely with the formulas we have. So for now, we've done the area, which is something you won't need to do. The equation, you won't find displacement off of velocity time graph. So if you can find the slope of that line, you're doing okay. Leave it at that before I blow up my brain here in front of you guys. That is kind of it. Did anybody have any other questions from that? I know that was the last question that we ended up at. Did I go over everything other than that last one using the equations? Excellent. All right. I gave you guys a provincial exam at the field trip a while back with Mrs. Ward. And it's right here, practice provincial. I have about 30 minutes left. Yeah, Taylor will go over that. I have about 30 minutes and I want to just dive into this a little bit. Number 1 on page 5, Taylor? Or number 1 on page 1? Page 1. All right. I'm just going to save this guy so I can load it into OneNote. Hopefully. All right, page 1. The pool ball below is photographed 8 times the equal time intervals. Pool ball motion uniform. How do you know? Sketch a D versus T and a V versus T graph, showing the general shape of each graph. All right, so a few days ago when we first went over this, we kind of discussed that each time the light flashes, the object gets a picture taken of it. And if we look at the object, it looks like each time the light flashes, the distance the object has traveled is the same. So that means that we are traveling with uniform motion because each time interval, the object is traveling the same distance. We call it D, D, D. They're all the same. So this is uniform motion. If I were to sketch a distance versus time graph, so if it says sketch, I can just do this, distance, time. So as time progresses, is the distance away from where I started, let's call this the start, is the distance away from the start increasing, or is the distance away from the start decreasing, or is the distance away from the start not changing? Well, it looks like it's getting further away. So each time the light flashes, it's gone a little bit further. So that means my distance is increasing. So I started at some point, we'll call it 0, and then as time goes on, the distance is increasing. So if I were to sketch a graph, it would look something like that. The second part of the question asks me to draw a velocity time graph of the same object. All right, so as time goes on, is the velocity increasing, decreasing, not changing? If I think back to the very beginning, it doesn't really look like the ball started from a stop and then slowly sped up. It just looked like it's been cruising along. So the velocity started at some level, and as time went on, the velocity stayed the same. The ball isn't speeding up. If it were, then the distance between the flashes would be increasing. If the ball were slowing down, the distance between the flashes would decrease. This ball is traveling at a very constant velocity. So that means that as time goes on, the velocity isn't changing. Does that help you out at all, Taylor? Great. Where did I save that test? Balancing, practice provincial. All right. If you don't have this test, that's fine. Shouldn't really matter too much. You can just kind of go through it with me. I can find my keyboard here. Most of you guys have it printed off. If you don't, you might want to print it off. I made yours super tiny sized, and it just kind of saves paper that way because these tests can take up a lot of paper. But just give you an idea of what the exam kind of looks like in general. So this is an old exam, and it's really good to go through these old exams because I kid you not, the questions just get recycled on exam after exam after exam. So if you can imagine there's 80 questions on exam, they maybe have like, a 500 or 1,000 questions they pull from. And if you look at lots of old exams, you'll just see the same questions over and over again. At the very least, the diagrams are always going to be the same. So you'll end up, the more tests you look at, the more sort of things you'll see that, oh, I've seen this question before, or a question like this. So when you get your test, it'll be a paper test. In the middle, there'll be a data booklet, the one that you guys have printed off. And what you can do is just tear the data booklet right out of the middle, and then you can use it. You're going to have a bubble sheet, and you're going to have a test booklet. And that's all you're going to have. So you're going to basically have 2 pieces of paper in front of you, a booklet with all your questions, and a piece of paper for all of your answers, just like a bubble sheet. So there are always going to be 80 questions. It always says suggested time 120 minutes, which is 2 hours, but you also get an additional hour, same as the math. And your data booklet will be in color, yeah, which is kind of nice, especially for the acid-base stuff, because the acid-base is always going to be colors. The biomes will also be in color, and that helps as well. Taylor, I'm not sure where. I'm gonna go with 99% chance that yours will be on a computer, Taylor, not on paper. I can confirm that for you, though. I think it just depends on where you go. but I think you'll be on computer. Everyone else will be doing paper. It's kind of obvious, and you guys have done lots of multiple choice exams, but a computer is going to mark this one piece of paper. If you do a poor job of filling in bubbles, like you fill in your bubble like that, a computer is not going to care enough to say, hey, somebody should kind of look at this bubble because it's kind of filled in, but it's kind of not, I'm not sure. A computer sees a bubble or no bubble, and it doesn't think, it doesn't have a brain, it just says, is that dot filled in, yes or no? Same thing goes if you are doing your test and you pick C, and then you go back and you're like, oh no, I'm pretty sure it's D. And then you like try to erase it, and then you fill in D, and then it kind of looks like this one's smudged, and then this one's filled in, and the computer sees two answers. And as soon as it sees two answers, it just automatically marks the question wrong. There will be no questions on this test that have more than one right answer. So just be careful with that as well. I would really, really hate, and you would hate, to know how to do something, get the question right, but have a computer mark it wrong. That wouldn't be really fair, and it happens. So just obviously bubble sheets, you guys know how to fill them out, but just be careful with how you fill it out. So the test is broken down into sections. It says life sciences, so this is biology. It tells you which pages of the data booklet to use. So it tells you you're going to need some chemistry stuff in this section. You're going to need carbon cycle, phosphorus cycle, biomes, and the nitrogen cycle. So you know the pages you need to look at for this section of the test. Physical or chemical factor in an ecosystem, the influence of growth of plants. So physical or chemical, it's going to be something that's non-living. Yeah, sorry, Ava, it's a good strategy. I mean, you could do that for sure. Circle the right answers as you go through the exam. That's one thing I didn't mention. When you're writing your exam, nobody's ever going to use the exam and nobody's going to mark it. Literally, when you're finished your exam, whoever's there is going to take all your bubble sheets, and then they put all the exams in another box. The exams go back to the Ministry of Education and they just recycle them. They don't look at the actual test. So if you have a question like this, you can write all over your test booklet, and if you circle, D, abiotic factor, because you believe that's the right answer, that's fine. This booklet won't get marked. No one's ever going to see it again. And you can write all over. You can, think about, okay, if I had a pond and I have some water, and then, there's like a tree next to it. You want to draw a tree, and you want to draw all over it, that's fine. You need a brain break. You want to draw a picture, that's fine. One thing that, just getting back to your question, Ava, when I do multiple choice tests, if I'm really sure of the answer, I'll bubble it in. If I'm a little hesitant on it, I'll leave it just written on the question booklet. Like on this page, I would have circled D, and then I would maybe come back to it. You want to make sure when you're filling out your bubble sheet, though, you don't get questions out of order, because that could obviously be a huge problem if you started at number 2 and then answered them all right, but you skipped one or something. So just be careful. Obviously, you guys will be careful. I personally don't like going through a whole exam and then going back and filling out all the bubbles. I would just fill them out as I went. If I'm unsure, I would leave it blank. Lots of people will do it that way, though, Ava, where they will look at it. They'll answer all the questions on the data booklet, and then they'll go back at the end and fill in all the bubbles. And one reason I would not recommend kind of leaving the bubbles until the end is, imagine if you had a really, really strict examiner, not just for this test, but for like university or future down the road, and they insist at 3 hours, they're taking your test away from you. Now, if you've left all of your answers on your data or your test pages, but you haven't filled out any of the bubbles and you run a little bit late, well, now you have a blank bubble sheet, and that's what they're going to take. So it's just kind of one of these things. If you're comfortable with it, you're aware of your timing, then you should be fine. But if you're starting to run late, it's better to have something on your answer sheet than to have nothing. I'm just going to, well, I mean, 2's a tricky question, so I'll look at it. Might as well. Which of the following biomes removes the greatest amount of atmospheric carbon dioxide? Now, we didn't explicitly ever talk about this in class. I never said this biome removes the most CO2 from the atmosphere. But through looking at the answers, you should be able to kind of use a little bit of reasoning to figure this out. So think about this. What in a biome would take carbon dioxide out of the atmosphere? So what in a biome is going to use carbon dioxide? Are people going to use carbon dioxide? Are something else? Trees, sure. And then we can go even more general. We can say plants. So we're looking for a biome with the largest amount of plants or trees. Well, that can be a bit tricky, but maybe we can figure it out from the answers we have. Does a desert have a lot of trees in it? No. All right. Tundra. No, that's permafrost. There's not a lot of trees there. Boreal forest is looking good, and permanent ice has no trees. So they ask questions like this because they want you to kind of demonstrate that you understand that a boreal forest has a bunch of plants in it and trees in it. And then a desert, tundra, and permanent ice don't have trees. Now, of course, we never said this specifically in class, but you can think about it a little bit and hopefully arrive at that answer. Which of the following is biotic, so living change? Now, use the following article to answer question number 4. So usually they'll put an article and then the question will be below it. It is kind of common sense, Anna, but you kind of get caught up in the moment on a test. You're like, I don't know, it's just going to happen. There's tons of these questions that are kind of reading comprehension type questions. They really, in my opinion, have no place on a provincial exam. They're not asking you about, your knowledge. They're seeing if you can read and synthesize information. This is probably a great question for an English exam, not necessarily a science test, but that's just the way it goes. So anyways, you read through the little story, you answer the question. This is kind of a tricky-ish question, not terribly bad. I'm not going to read through it right now, but I'm just going to kind of skip ahead, show you a little bit more of the test. Use the question to answer number 8 again, reading comprehension. I will go through the answers to this test eventually. We just don't have enough time. Again, chromatograph, talking about biomes. Number 12 was tricky as well. Lots of reading stuff on this test. It's pictures, predator-prey, erosion, natural selection. All right. We made it through that section. So that was 22 questions on biology. And that was out of 80 in total. And that's pretty standard. So about a quarter of the test is on the biology. Yeah, for sure. I read the best way to go through those questions where you have to read something is to read what the question is asking. Keep it in mind as you go through it. That would be a great strategy, actually. So read the question first, and then go through and read the information that's kind of given, the little blurb, and then you'll be able to kind of look for what is actually being asked in the question. That's a great strategy. Yeah, for sure, Abby. And yes, Alex, there will be motion on the provincial. We'll get to that. So first 22 questions biology, and then it says physical science. So this is the chemistry section of the test. Use your periodic table, elements, pH scale, names, formula, common ion sheet. you go through subatomic particles found in the nucleus of an atom. You mean you've done that stuff since grade 8. You should be pretty good at that by now. Lewis diagram, Bohr model stuff, Bohr model, Lewis dot structures, diatomic molecules, indicators, periodic table questions, naming covalent molecules, naming covalence, balancing. You'll notice the balancing questions, instead of asking you or showing you a fully balanced one, because then you can just count, they'll say, hey, what coefficient do I need to put in front of oxygen in order to balance this? So without giving you the answer, they're just wanting the coefficient in front of that one question. And then similar here, they're asking for a full set of coefficients. And if they give you a full set of coefficients, what you can do is you can put them in. So you go, okay, 1, 1, 1, 1, 1, and then you can count. Instead of having to actually physically balance it, you can also substitute the answers in, okay, that one didn't work, 1, 1, 2, 1, 1. And you can count. Does that one work? Maybe, no, yes. So you don't really, if you can count, you don't need to know how to balance, but if you know how to count, you probably know how to balance anyways. Pentane combines with oxygen. They're asking for a balanced equation. There's always a question like this, and this one was interesting because I did a demonstration similar to this. This is copper 2 sulfate. I use copper 2 chloride and iron filing. So they're putting iron into here, and then they end up with a bunch of copper. They're showing that the stopper's on top, so it's a closed system, so nothing's entering or exiting. You'll notice that the mass doesn't change. I've seen questions with a similar setup. They have like a beaker, and then they have some acid in here, and then they put a piece of metal, and there's little bubbles coming off it. And they say, what type of gas is being produced? It's hydrogen, usually. So it's asking the type of question, or the type of equation. You have iron filings, so that's Fe is iron. Copper 2 sulfate is going to be CuSO4 maybe, and then you get FeSO4 and Cu. And it's asking what type of equation is this. So in this case, it's a single replacement. The iron is by itself. It kicks the copper out. Now the copper is by itself, and then the iron is in the equation. So single replacement type reaction. Just a bit of a different way, showing you a picture instead of saying, hey, this happens. There'll always be at least one question like that on there. Law of conservation of mass, acid and neutralization. Number 45 was a tricky question. Number 42. Yeah, Abby. Pentane combines with oxygen forming a gas and water. Which of the following represents a balanced equation for this reaction? So just like the math provincial, there's always two that if you knew a little bit about something, you could usually cancel out at least two of the answers. And in this case, we talked about the magic 7. Oxygen, chlorine, bromine, iodine, nitrogen. I forget what they all are. 1, 2, 3, 4, 5. I'd have to look at a periodic table. I don't have one in front of me, but these are diatomic. O2, Cl2, Br2, I2, N2. If I look at oxygen gas here for the first 2 letters, I see that it's not diatomic. So I can automatically get rid of A and B because they're not diatomic. If oxygen's by itself, it has to be diatomic. Now, it's asking us to balance. So I can count, and maybe I'll start with carbon. See 5 carbons here, 5 here. That looks good. With combustion type reactions, you're going to end up with oxygen being a problem. Oxygens, I have 5 times 2 is 10, plus another 6 is 16 oxygens. But on this side, I only have 5 oxygens, so it's not C. It has to be D. Does that answer your question, Abby? Or am I just skirting the problem? Where can we find the law of conservation of mass? It wasn't the laws of conservation of mass, there was just one law. Law of conservation of mass says matter can't be created or destroyed. Basically, if you start with 117.35 grams, you must end with 117.35 grams. If you start and end with the same amount, it follows the law of conservation of mass. If you start and end with different amounts, it doesn't. And we did talk about like nuclear reactions kind of violate the law of conservation of mass. They don't really, but they do. Anyways. So this experiment provides evidence for the law of conservation of mass. You'll notice that again, it's kind of like an English type question. You get words like supported and refuted. Supported means agree, and refuted means disagree. If you run into words that you don't understand the meaning of in your science provincial, put up your hand and ask, hey, Mrs. Ward, I don't understand what refute means. And because you're asking a question about English, not necessarily science, the person may help you. I'm not saying they will for sure. It's kind of a judgment call for them. But it's kind of weird that they have this not complex language, but supported and refuted, kind of different things than you've probably heard before. So the statement is supported by the information. The mass doesn't change. It stays the same for both. So it's supported. All right, I'll just fly through the end of this. So 46 now. The first section had 22, so 46 minus 22, so that 24 questions on chem. So far, 22 questions on bio. So there's 80 questions, we're up to 46. So over half the exam is chem and bio. Just over half. Physical science is radioactivity. Technically physics, but it kind of looked like chemistry. This is a really small section. Tells you what page is your data book to look at. Alpha, beta, gamma. Half-life questions. There you go. Really short section. Then the next one is motion. So this is physics. I'm not going to give you guys a specific physics review. I mean, we've just covered it. What is the displacement? Please, please, please promise me you'll look at the axes of your graphs and determine if it's a velocity time graph or a position time graph. Super commonplace, students will make mistakes. Don't make it be you. It's position time, position time, position time. This one might not even have a velocity. There you go. Now it has a velocity time graph. Of course, a horizontal line on a velocity time graph means something different than a horizontal line on a position time graph. So be careful. Be careful, be careful. Nice little ant asking about the graph. Leaning Tower of Pisa, we actually talked about that in class. Galileo dropping those two mass stones off of the Leaning Tower. Superman, cool. And then we have earth science. Abby, you had a few questions out of earth science. This is the end of this exam. So earth science, make sure you use your data booklet for your images. That's it. It says end of examination. You're done. Is there anything you wanted specific out of there, Abby? I am going to wrap my brain around the question from the learning guide, I apologize for not being able to figure out how to do it on the spot. Number 10. So I'll get back to you with this next day for sure. And again, I apologize for not having an answer for you for that. If you are able to submit, if you just do the second part, just the area calculation, that's all I'm looking for. So that's good if you can get that done. Of course, that's kind of it for Unit 9. We've gone through it. You should be able to submit that learning guide. You can bring it to me tomorrow, or you can submit it online. Hopefully you can get the Unit 9 test done by Friday. That's kind of my goal. If you can't, then just send me a message. But really, all of our stuff should be done by this Friday. Hope that can be accomplished. It seems pretty reasonable. I'm going to go through these questions with whoever wants to stick around and go through them. I know the calendar said that we'd only have class till 10:20 today, but I don't have to teach at KSS right now, so I have a few minutes. So if you want to ask questions about this exam, I'll go through them. If you want to sign out and get your day started, that's fine as well. So I'll leave anyone who wants to leave. You hopefully will see me tomorrow at KSS, about 8:45 in the front foyer, room 141. I said I'd drop a map of KSS. Here we go. KSS is a big square. Right in the middle is the gym. And these are the front doors right here. And then right in front, inside the front doors is the multi-purpose room, also called the MPR. So if you walk right in the front doors, I'll be sitting right here. Hi. If I'm not there, if you want to get to the classroom yourself or you show up a bit late or something, if you go in the front doors and you take a left, room 141 is right here. Or you can go in this door on this left side of the school and just go straight into room 141. The teacher who teaches in that room is Miss Kulak. And she was nice enough to donate her classroom for us for the day. So we'll hang out in the MPR at the front of the school for until about 8:55-ish. It kind of gets busy at that time, so there'll be tons of students in there kind of milling about, maybe 8:50 or so. After that, we're gonna just meander down to room 141. So if you go in the front doors, take a left, take a right, it's on. Down the first hallway. And KSS is super easy because it's just a big square, so you can't really get lost. If you want, you can just go in the left doors at the front, straight down that hallway, and then it's on the bottom floor, room 141. So if you want to come in with me, meet me in there. I will take you down to room 141. We can go as a group, but I'm not going to just sit there until everyone shows up. Because some of you are going to probably show up a little bit late or early or whatever. If I'm not there, you can go straight to 141 if you want, or you can hang out in the MPR. Either way, we'll get you to room 141, hopefully. And there you go. So we'll see you guys tomorrow. Abby, 69, 73, 76, and 80. Jump through these real quick. 69. So the S waves can't go through a liquid, and it says right on this diagram solid liquid, and it's just kind of one of those memorization things for 69. So hopefully there's a D somewhere in here. Yeah, letter D, D. So because S waves can't travel through a liquid, remember they showed if we had an earthquake happening right here, the P waves would go through and then they kind of get like bent a little bit. So that's a P wave. An S wave would physically get blocked. So the S waves can skirt around the edge, but they won't make it right through that liquid because that outer core. That's a good point that the upper mantle is semi-liquid. When we say semi-liquid, outer upper mantle, think of it as like it's hard to describe how thick it is. It's almost fluid, but it's not really. Don't think of it as a liquid. Think of it as a solid that kind of moves. I don't know, that's probably a bad way to describe it, but it's not as liquid as you might think. 73. Which following tectonic mapping symbols would correctly show this plate boundary on a map? So we have this, the Indian-Australian plate is going under the Eurasian plate. And they've kind of shown it as a convergent boundary, and you can see that this plate is actually going under the other plate. So letter C is a transform boundary, so I get rid of that. Letter A is a divergent boundary, so I don't want that because these two plates are coming together. What other choices do I have? That's it. So remember, A is divergent. This is a transform. And this is convergent. Oh. Getting a bit ahead of myself. That was fun. Which of the following locations can deep focus earthquakes occur? With a transform fault, you have, I'm going to attempt to draw a three-dimensional image here. So these are my two plates. One is going that way and one is going that way. So transform fault, you have plates sliding past each other. Earthquakes don't tend to happen at deep points because they can happen, right at the surface. They don't have to happen down deep. So anything with a transform fault, because your plates are moving past each other, your earthquakes are going to be really shallow. I was just wondering if earthquakes can occur at divergent boundaries. You'll get really minor ones, but not typically. So you can get rid of divergent. Oceanic continental and continental continental. When you have two continents coming together, think about like the Himalayas. Those are really thick plates. The deep focus earthquakes are going to happen at a convergent boundary that has a subduction zone. So with an oceanic, and then you have a big, thick continental plate. Because that plate is being subducted, you get really deep earthquakes way down in the bottom where the big continental plate, where you get that ocean plate going under it. So because it's getting subducted under it, you get really deep earthquakes because they're in contact very, very low down all the way until they start to melt. And then you get your volcanoes and stuff happening here. So no, in general terms, don't think of earthquakes happening at convergent boundaries. Or divergent boundaries, sorry. 76. Which of the following factors is responsible for the continued motion of the Explorer plate off the coast of BC? So, did I only steal that page? Okay. So I find my data booklet, here's the Explorer plate. And then I gotta figure out why is that plate moving. So you can see that there's a bit of a divergent edge, meaning that it's getting pushed kind of this direction, and then it's getting subducted there. So you have the Explorer ridge is causing this plate to kind of get pushed in this sort of direction. It's getting subducted under the big plate. So which of the following factors are responsible for the continued motion of the Explorer plate? It's kind of tricky. I would go with slab pull and ridge push. Ridge push means that you're going to get the push on the one side, and then the slab pull happens as it gets subducted on the other end. I would go with A. Mantle convection is actually what would start the plates moving, but I don't know if it would continue them moving. I would not choose mantle convection. That picture was there. Obviously, you forgot to look. That's okay. And 76 and number 80. Last question on the test. A trench occurs. You get trenches at convergent boundaries because you have a big subduction zone happening here. You have your big continental plate. You need to start to learn how to draw these diagrams a bit better. All right, so here's my big continental plate. I have some ocean. This is where your trench is. And trenches occur at subduction zones, at convergent plate boundaries. You get, at rifts, you don't get trenches. Faults are at transform, ridges at divergent. That's perfect, yeah. All of that is completely correct. So trenches happen at convergent boundaries, usually continental oceanic plate boundaries, because you get the small oceanic plate going under, and where it meets, where the two plates meet, you get a trench forming. If you have plates moving apart, magma pushes up, you get a ridge, mid-oceanic ridge, and then transform faults just slide past each other, so you don't really get much happening at those, other than earthquakes. Hopefully that was good, Abby. We'll go through the entire test eventually, and if you run into more problems, we'll have time to go through that as well. So there you go. I'll leave you guys for now. Have a great afternoon. We'll see you guys tomorrow. Thanks for sticking around.